Okay, we're going to take a look at some word problems involving solving quadratic equations by factoring. So, what do we have here? Three consecutive even integers are such that the product of the first two is 6 less than 9 times the third. Find the integers. What a mouthful. Let's really dissect this one bit at a time. So, three consecutive even integers. So, the way you guarantee that a number is even is by doubling it. So for example, we know if we let the first integer be x, well, if we pick 3, 3 isn't even. But if we do this and put a 2x there, we know that whatever we plug in for this number, the result is going to be even. So let's see here. We've got 5, plug it in, 2 times 5 is 10. That's even. So that's how we guarantee something is even, is by doing that. And then, of course, the next consecutive even, well, how do you get from 2 to 4, or 4 to 8, or 8 to 2, 4, 6, 8, 10, 12? I missed 6 there for a second. How do you do that? You go up 2. So the second number, so we're going to let the second integer be 2x plus 2. And we're going to let the third integer be 2x plus another 2, or plus 4. So now we have three consecutive even integers are such that the product of the first two, so the product of the first two is 6 less than 9 times the third. So these are not equal. This is 6 less than this, right? The product of the first two is 6 less than this. So in order for these to be equal, we have to either minus 6 from this side, or we have to add 6 to these because we know these are 6 less. So here I've just written it up like that. And again, it's going to take some practice for you to translate from English into math, but if you keep practicing and you keep listening to people explain it to you in a way that makes sense, you're going to pick it up just like you've picked up everything else in life. So now let's go find the integers. So we're going to have to do some simplifying. So first I'm going to distribute this 2x in. So I've got 2x times 2x is 4x squared, and 2x times 2 is 4x. And then here I've got 18x plus 36 minus 6. So now I'm going to bring everything over here and let it equal 0. So I've got 4x squared plus 4x minus 18x minus 36 plus 6 equals 0, right? All of these change signs when they go over the equal sign. Then I'm going to collect those two and collect those two. So I have 4x squared, that minus that is negative 14x, and that is negative 30x, negative 30. And so now I'm going to do what I've done before. I'm going to see if I can reduce all these numbers. So 4 doesn't go into all of them, but 2 does. So let's divide everything by 2. And now I'm going to factor this trinomial. So you've learned different ways to factor trinomials. What I'm going to do is one of the methods, and then we'll continue on. So I've got here 2, so that's 2 and 1 and 1 and 2, and then here 15 and 1, 15 and 1, and 3 and 5. So I have to figure out which are going to subtract to 7. So 1 times 1 and 2 times 15 is 30. So 1 and 30 do not subtract to 7. How about 5 and 6? Those don't subtract to 7. That times that is 2. That times that is 15. 2 and 15 don't have a difference of 7, but 10 and 3 do. So I'm going to circle those two. So now I know 2 and 3 go into one bracket. 1 and 5 go into another bracket. We know there's a 1 there. Just going to put a little equal 0 there, squeeze it in. And then I'm going to have to figure out my signs. So when I multiply these, I know the signs are going to be different, but I have to make sure it ends up with -7. So this is 10, and this is 3. So -10 and +3 give me -7. So now I'm going to solve. So I've got 2x plus 3 equals 0. So 2x equals -3, and x equals -3 over 2. And then here I've got x equals 5. So 3 consecutive even integers. So now you have to know, what is an integer? Well, fractions that don't reduce into a rounded off whole number, even or positive or negative, are not going to be an integer. So we're going to say, go like this, and we do this so that it's light enough to be able to see it, but clearly communicating to the person who's marking our work that we're not considering it because of integers. Okay, so now if x equals 5, we now going to answer the question. So it says, find the integers. Well, the first integer was 2x. So I'm really running out of room, so I'm just going to put it up here. So the first integer is 2x, so x is 5. So here we've got 2x, or 2 times 5 is 10. And then, of course, 12. And then, of course, 14. And so therefore, the integers are, really squeezing it in there, 10, 12, and 14. All right, let's take a look at this rectangle. So here we have a rectangle. It's 24 centimeters long and 16 centimeters wide. You don't need to worry about putting units in your diagram. You just have to make sure your units are in your final sentence. So a rectangle is 24 centimeters long, 16 centimeters wide. When each dimension is increased by the same amount, so let's increase by something, but the same, the area is doubled. What are the new dimensions? So before we added this, it was 16 and 24, and we know the area of a rectangle is length times width. So what is 16 times 24? Well, I don't have a calculator handy, so I'm just going to do it here on scrap paper. 16 times 24, that's 4, carry the 2, 16, 17, 18, 0, 24, 4, 2, carry the 1, 4, 424. Okay. So the area originally was 424 centimeters squared. Now, squared, right, because of area units. Now we're going to double it. So I know how to double it. So now the area, so the new area equals 848 centimeters squared, because this doubled, or times 2 is that. But I also know the new area is this length and this width here. So I can say 24 plus x times 16 plus x equals 848. And now I have to FOIL out my brackets, bring everything over, make sure it's in descending form, equals 0, divide and reduce if I need to, and then factor and solve. So let's do it. We already know that 24 times 16 is 424. This times this is 24x. This times this is 16x. Oops. This times this is x squared. I'm going to do minus 848 equals 0. And now I'm going to put everything in descending form and clear it up. These two are going to be collected, and these two integers are going to be collected. So I have x squared plus 40x, and then this and this is minus 424 equals 0. So I'm going to need to figure out how to factor this, and typically if you're given something like this and it doesn't come to mind what to do, what numbers would be correct to sub in and factor, then what you need to do is you need to use the quadratic formula. Okay, so I'm going to leave this for you, and I'm going to continue on with this one, and then we'll take this one up next time. That's your homework to take a look and try to do. So here I've got find the quadratic equation whose roots are this and this. So basically they're saying we're going to give you the answers. You work backwards and find out what the actual quadratic equation is. All right, well, we can do that. So if x equals -3 or x equals a half, then that means that x plus 3 equaled 0, right? And this is 2x equals 1, right? When we divided both sides by 2, we ended up with a half. And then I'm going to do this. So these are the two things that are in my brackets. And now I just need to FOIL. That is 2x squared. That times that is minus x. That times that is 6x. And that times that is minus 3 equals 0. Collect these two, so I have 2x squared plus 5x minus 3 equals 0. Bada bing, bada bang, bada bung. So we're done for now. And again, make sure that you do this one and figure out what multiplies to 424 and subtracts to 40. And if you don't want to do all that sort of going through the way I did here last time, going through all of the options, then what you need to do is you need to use the quadratic formula. Okay, let's see what you come up with, and we'll take it up